also do regular analysis on passenger vehicle fleets for various clients. I have a good understanding of the distribution of energy demand within a wide variety of sectors. I think that's
Shall I go for it?
Yeah.
Hello, my name is Ben Madden. I'm one of the partners at Element Energy, which is a specialist low carbon energy consultancy, generally working on the sort of the technologies which are emerging that we're going to need to solve the energy crisis. We've recently been acquired by the ERM Group, which is about a 6,000 person firm of environmental consultants, so helping us to broaden our reach. I head up our hydrogen team. At any given time, we've got between about 30 and 40 consultants working on hydrogen projects, mainly in the UK and Europe. And I guess we do two types of things. One is classic techno-economic and strategic consultancy for corporates, governments, due diligence, that kind of thing. For example, we provide the secretariat to the UK H2 Mobility Group of industrial players. But probably what I spend most of my time doing is what we call project initiation, which is basically knocking heads to try to make projects of progressively increasing scale happen. And as a result, we've had our hand in, I think it's fair to say, a decent majority of the hydrogen projects that have been deployed on the ground. So hopefully we can give some insights into the buses, the cars, the trucks, etc. And these days, most of my work is on effectively trying to expand those trucks and buses in particular, and also green hydrogen production in the UK, but particularly around Europe at the moment, where the policy environment is perhaps a bit more grey.
Thanks very much, Ben and panelists. Sean, I'll start with you if that's all right. From the OEM perspective, what do you see as the biggest challenge associated with manufacturing and supply of hydrogen vehicles, and specifically into the UK?
I mean, there's a wider question actually which applies for all vehicles. Of course, UK is right-hand drive. This is a serious issue when we think about most OEMs in Europe are producing predominantly left-hand drive vehicles. So encouraging any vehicles into the UK, particularly new technologies, is a real challenge and shouldn't be really overlooked. But in relation to fuel cell vehicles, well, frankly, the fuel cell technology is entirely scalable now. There is no limitation at all in relation to vehicles themselves. The issue is entirely around the availability of hydrogen and the dispensing capacities, the reliability of the stations. Hearing earlier on about the station, it's ensuring that people can be confident that they can refuel when they need to, where they need to. Prices go up and down as they do with petrol users, but at a reasonable price that's accessible. So the barrier today is around the availability of hydrogen.
Chris, you mentioned the time for trials is over. So can you expand on that a little bit in terms of getting vehicles to market?
Yeah, of course. And Toyota, I think your program's about 25 years old. We've been at it for about 20 odd years. And as John mentioned, the technology works. It works great. The real big issue is I wouldn't actually say it's just the hydrogen infrastructure. It's actually access to those vehicles with a strategy to start deploying. So we talked about scale. If you can create something that works commercially within a region, but have a plan to scale it, it will scale very fast. And I think, in terms of passenger vehicles in the UK, they might need to be about 30 gigawatts of hydrogen production. That's significant for all of our road vehicles, and we can get to that stage.
Ben or Nick, do you want to jump in on this one?
I think it's clear that it's the lack of ability to refuel which is the problem. I think in the UK specifically, we've now got no shortage of companies that are ready to go and build fueling stations for you in a given situation. It's great news, the market is starting to emerge. In fact, they've got not enough projects built. The thing we have a real shortage of right at the moment is gas. So over the next 2 to 3 years, there is just an absence of plausible gas that can go into those fueling stations. So we really do need to see some investment in hydrogen production, whether it's for dedicated for industry or for transport. It's really important that the kind of projects we heard about in the previous session actually get built.
Okay. So rather than just reiterate what everybody else has said, I'll try and pick another topic as well. So obviously access to hydrogen refueling is critical, we need that. Another thing that's lacking as well in terms of uptake, I think, is variety of models. We've learned from the electric vehicle uptake as well. The more model types that are available, the greater the market is. Then they start to become this, you're going to make an increased demand for hydrogen for the refueling stations then. So we don't just want nice saloon cars, we want smaller cars as well, and light commercial vehicles and off-road vehicles and big SUVs and everything else. That's the more models available, the greater the uptake will be as well.
Is that something you can comment on, John? You talked about, there's not everyone's a medium, and you've got Converse, of all varieties. So is that something that you'd also echo?
Yeah, I mean, you need to, it's quite clear you need a range of products, and the barrier in terms of the development of the products is actually not hydrogen. This is in terms of fuel cell. It's the electric powertrain. It's the electric motors, it's the power control units, it's the powertrains for particularly commercial and heavy duty vehicles, which need to be proven out. One of the questions around timing and why do trucks take so long to come? You can do all the analysis of the bench test that you want, but until you put something into practice in the hands of operators, you will not prove it out, and that takes time. That takes road miles, and that takes time. But in the meantime, we've got technology that can be scaled. Passenger cars will drive the cost of fuel cells down, will demonstrate the reliability and durability of fuel stacks and technologies around that.
I think it's worth noting kind of where we are today and kind of where things are going to. Fundamentally, it's a relatively promising story. Today, if you want to get involved in hydrogen transport, you can buy basically a Mirai or a Hyundai equivalent hydrogen car, or you can buy a number of different buses. That's basically your option. And then there are a series of people that are starting to arrive. We're starting to see vans coming and trucks. We see some sort of SME type trucks available pre-2025, but the big truck manufacturers have serious programs to bring trucks in the second half of the decade. So we are going to start to see the beginnings of that sort of make model. Well, it's not make model, it's a bit extreme, but certainly diversity of options coming. Vans pre-2025 and sort of medium-sized trucks, and then larger trucks post-2025. So we will actually start to be able to create some of these sub-concepts. Lack of availability of a wider range of vehicle types has definitely held the sector back for the last few years.
The example of California in terms of hydrogen infrastructure and hydrogen fueling stations has been raised a couple of times already. So then you mentioned that there's not a lack of people who are willing or able to start refueling infrastructure rollout. So what is it that's holding back specifically, or is it entirely down to hydrogen supply?
No, I mean the fundamental thing that's holding hydrogen back is the absence of a plausible business case in the country, which is a function of the policy environment in which this whole thing is happening. So, I mean, within the UK Sustainability Group for some time, we've been calling for two specific policy interventions. One is a per kilo support scheme, which would effectively help with the early introduction of hydrogen when the hydrogen price is relatively high. And the other is obviously a vehicle subsidy program to help with early purchase of vehicles when the vehicles are too expensive. And we've seen government sort of dancing around that issue for at least the last 4 years, not being willing to make a kind of firm commitment to the sector. So sort of the absence of a clear policy commitment to move from trials to an actual commercialisation program is the number one thing that's holding back hydrogen in the UK. And then as a consequence of that, we don't see the investment in hydrogen infrastructure, we don't see the investment in stations. That would be my case.
Yeah, just on California specifically, because we've spent a fair bit of time out there now, there's a different policy regime out there. Clearly, at risk, the state has put in quite a few rules already. There's about 50 in the state, I think there are about 13,500 cars on the road. No problem with uptake. There was some subsidy for vehicles as well. And they're trying to break the chicken and the egg, because it's clearly an issue where there's not enough infrastructure, there's not enough cars. So what the California state have done, this is the Air Commission, have put in place capital funding for refueling infrastructure. So we'll pay for the refueling infrastructure through a bidding process. At the moment, we've got Shell and Chevron looking to roll out 50 new passenger stations each. There's up to 200 in total, so 15 now, 150 in planning. What they've said back to the manufacturers, we'll deploy that capital with vehicle deployment. This is my focus on the vehicles, why it's a lack of concentration of vehicles of all types in a region to demonstrate it works, to create commercial liability for the refueler and hydrogen production.
To move back to the discussion around could be the misleading comparison of efficiency losses. That's very much the first thing that comes up in these conversations. So John, it's really good to see you make the point that it's vehicle efficiency is completely different to electrical efficiency. So how do we try and promote that or amplify that message, and how important is that?
How important is it? I mean, I don't think any of us, apart from the price of gas, a petrol pump, really think about the efficiency of a combustion engine, which if it gets to 30%, be lucky, maybe a few hybrids get to 40%. I think this is an academic argument. This is an academic argument that particularly in government has resonated very, very strongly, and they can't see beyond it. And I think this is a terrible indictment, in a way, of where we are in a number of different areas, where we have these siloed academic arguments which will dismiss everything else. We have no silver bullet on anything. We need to look at all the options, we need to align them together. Absolutely, it is an efficiency question when you're converting something into hydrogen and then compressing it, dispensing it and using it, absolutely. But my argument is that if you can produce that energy in the most efficient location with your renewable and actually distribute it in a way that you couldn't with anything else, then that surely has got to be our best route to take. So I agree entirely with the efficiency point. It's a thermodynamic, physical reality, but it has no bearing, in my mind, going forward.
Anyone else want to jump in?
I mean, all I would say is it's quite hard, because the efficiency argument is a very simple argument, and the arguments John's making are harder. So trying to find ways of simplifying the argument so that the likes of the politicians can understand it is important. My one-liner is, you're not comparing light with light, because the energy input you're starting with in your efficiency argument is completely different in either world. But even that is a bit sort of contrived. So I think you just have to accept it's a hard argument and try and sort of keep hammering away at it.
I mean, the one thing I would say is that hydrogen is a new route to market. So we mentioned additionality earlier. So this is a new route to market for energy that wouldn't be already on the grid. And so we haven't got a lack of energy, we've got too much energy in the world, as we know, we're struggling with it. But it's being able to harness that in a clean way and store it and use it. So it's a different route to market, and with the two technologies, decarbonise much, much quicker if that's important.
Yeah, absolutely. And just like that, so I think a lot of us are guilty as well. And part of the reason the governments have latched onto this efficiency argument like that is we make simple arguments based on averages. And we do that because, we're taught to do that in university, right? Yeah, you have your data set, you take an average of it, that's what you design for, and maybe put in a safety factor. But when you're actually looking at use cases of individuals, that average isn't representative of the journey that a person makes over a year. And we need to make that argument as well, that you're going to struggle to meet those peak demand journeys. That was discussed earlier. It's not just about range, it's vehicle weight and range, and how many shifts is that vehicle working? There are passenger vehicles out there which are double shifted. It's very difficult to electrify those. Okay? So it's that treating the whole passenger car market as an average value is a flaw in our thinking, and I think that's one of the things we need to overcome.
Right, open up to the floor now. Anything? Yes, questions? Yes.
Yeah. Hi, Romy from the University of Kent. John and other panelists refer to infrastructure for hydrogen distribution as one of the key barriers in the face of rolling out FCEVs out there. I understand that to a large part this falls on central investment from government and companies like VOC that presented today. But what about car manufacturers themselves? Can they play a role in that pyramid at all? And I'm thinking about, for example, Tesla Supercharger program, which gives some assurance to Tesla purchasers, as an example here. Is there something like that in car manufacturers pyramid at all?
I mean, in relation to, say, electrification, I mean, we're lucky. We're in a country which has pretty good electricity. About 1.2 billion people don't. If I'm building my charging infrastructure, I'm reliant on that infrastructure that's already been built. So I put a box on the wall, I put my name on it, and I've facilitated the delivery of energy that's already there. Hydrogen is an energy shift. It's a global energy shift. And it's something that will take decades to embed. It's not a role for automotive manufacturers. It's not actually a role for isolated individual companies. It's a strategic role, and it's got to be a global role, which is what the Hydrogen Council, which is an amalgamation of commercial entities, so it's 140 companies now, which are on a mission to deliver this, and the world's largest companies involved in this program. So it's not an OEM. I am no expert in dispensing hydrogen or the hydrogen supply chain. But what you can see is the integration of energy across sectors allows everybody to get a piece of the pie, if you like, and invest accordingly. And it's about aligning that. But what we can quickly do today is deliver certain hydrogen transport solutions which will have an immediate impact and have benefit. And it will grow over time. So no surprise that only a small number of vehicles are sold. 51,000 fuel cell vehicles in the world. 15,500 passenger cars were sold last year. That's a tiny, tiny number. But it's what we have to do to prove out the case. This is the long term. This is the long game.
I was going to just quickly add, I mean, you can imagine over the years we've tried to persuade car companies to take that role with all sorts of fancy mechanisms, but they want to just make vehicles, basically. What we are seeing, particularly in the heavier duty vehicles, and generally stimulated by the fuel suppliers rather than by the manufacturers themselves, is partnerships, where you're starting to see a kind of combined offer to the customer of station plus vehicle. So I guess the best example of that is in Switzerland, where we see the Hyundai trucks being offered alongside a kind of joint venture, which Hyundai also have a stake in, to sell fuel. And I think we'll see more of that, but more as a partnership thing rather than an OEM and their thing.
Just on our point, because we're offering out the service, we end up being the wholesale purchaser of the hydrogen, so we have a bit more control over where it goes. And we've been pushed quite hard to say, well, why don't you put your own fueling stations in? Well, clearly we don't have enough vehicles to do that in the short term. So we've partnered with national retailers to do that, and we're doing the same in the US, because they're the experts at that. But again, we encourage them to make sure that anything that they do invest in has public-facing utilities, for trucks, for buses, for cars, not just a depot-based, which doesn't make sense.
Matthew Easton, Transport Scotland. Question for you, Chris. I think you said during your presentation that you were getting, I think, 300-mile range. 300-mile range for 15 pounds. Is that right? Yeah. So it's interesting because that's what I get in my battery electric car at the moment, based on current energy prices. So it's interesting that you're able to achieve that now with hydrogen fuel cell vehicle. And I was wondering, a related question. In terms of scaling, you've obviously got some examples of potential vehicles you're looking to manufacture. I was wondering what your strategy is in terms of, as a relative startup business, scaling to low volume manufacturing.
Yeah, so on
particularly in the UK.
Yeah, that's okay. Yeah, so the efficiency side again is around design from a partnership paper. So working around the characteristics of hydrogen. Hence, we have a very low powered fuel cell. We don't need a lot of that. We recover huge amounts of energy from braking, and all the efficiencies, all of these will improve with technology over time and scale as well. And we'll continue to do that even with bigger vehicles. And the 300-mile range and 1.5 kilograms of hydrogen, that's for a two-seater, by the way. And the bigger ones will, I think I put on there, about 180 miles to the gallon. But we want to come in about the same cost level as a diesel Golf, as a low-end diesel Golf. In terms of the scale up, so we have two big partnerships that you're probably aware of, so Siemens and DHL Supply Chain. So they're our partners to help us with the scale up side, and our optimal throughput is about 5,000 vehicles per factory. So we'll have multiple vehicle factories in the UK making different models, Scotland, Wales, England, and the same around the world. So we'll go from a few to 5,000, not quite the 300,000 that Total will do in their plants.
Time for one more. Gentleman back there.
Florian Tudor, Metacon. We sell refueling stations, hydrogen refueling stations, and one of the often objections that we get from the customers before investing is the standardization, the type of the pressure nozzles, all these that are to be installed. And since it's a long-term investment, this is a valid objection from them. What should they expect for the future? Is in the automotive manufacturer focus on offering standardized solutions. 350 bar, 700 bar. China is starting to use 350 bar into the cars. In Europe, there is a focus on 700 bars into the trucks. What is, from the panel perspective, the situation?
Let me give a little bit of a view. Back in 2009, the program started to standardise passenger car refuelling, the protocols and the pressure standards. And that came to 700 bar refuelling with a certain type of protocol which has evolved since then. So actually for passenger cars there is a complete standard. Wherever you are in the world, you've got the same connector, you've got the same standard. That's what it should be. In China, slightly different because China's own legislative requirements and certain other stipulations, they have first of all worked with the 350, which, without getting into the details, is storage of gas essentially, the pressures. But within the other areas, there are different needs and it will evolve, I believe. Today, it's cheaper and easier to build a 350 bar gas station, and therefore that makes a lot of sense when you've got very low scale. And it's perfectly adequate for the buses, as we've had since 2011 in the UK, for example, at that scale. But as you go forward and the technologies become better and cheaper, then it makes a heck of a lot more sense to get a lot more into your vehicle so that you can go further and have better utility. And that can mean you have fewer stations, but also means it's much more flexible in terms of what you do. And combined with improvements in efficiencies means that the investment overall will come down for the whole of the network. Then you've got cryogenic hydrogen, which may require, which is a very, we get to high density, get a very long range, or maybe supercooled liquid hydrogen. These options will apply to certain sectors, and the technologies will evolve to potentially see them go into other areas. But I'd say, 700 bar passenger cars is pretty much, that is the standard. 350 for most commercial vehicles now for the time being, and the other two technologies will become specifically rolled out probably towards the end of the decade and into the 2030s.
Pretty perfect answer. The only thing I'd say is that the trucks that are going to come from the big OEMs, the big European OEMs, they're going to come to 700 bar. So I think if you're making a plan for 350 bar only truck refueling, when the big OEMs stand up, they're going to want to do 700 bar, and the reason they want to do that is they want to offer a clearly differentiated product with a longer range relative to what the battery electric option can offer. So I think from the perspective of a fueling station manufacturer, you need to be a bit careful about a 350 bar revenue strategy.
Yeah, and from our perspective, we're at 350 bar, but we can move to 700 bar. And I wouldn't want to just pay a lot more for 700 bar hydrogen, but it appears that that's what's going to happen. It's going to be the same price for 350 or 700, and we'll adjust to that.
One last one.
Hi, thanks. Michael from King Gas again. I've got a question primarily for John, please. Just a bit of devil's advocate. I think you definitely convinced me that the discussion of passenger vehicles specifically is definitely not over, and one should definitely be reopened. But I think broader, outside of obviously the stakeholders in this room, there's a bit of a perception amongst government, potentially, and the public, that it's almost a finished conversation that battery electric is the future for passenger vehicles. But why do you think that's the case, and what can we do to sort of get that message across that you present about today?
I could go on that for quite a while, but there is a political play here. There are a lot of vested interests which are driving certain agendas. The answer, that's a simple fact. And I think that there is a huge education piece that's required around hydrogen and the realisation of the total picture and how that fits into the energy sector, whether it's for heat, power, transport, industrial, or whatever. These things are starting to become more apparent with people, with the discussion going. And my involvement started when we introduced the car in 2014 onwards, and I can tell you, and Ben's been in it much longer than I have, that the difference in understanding, even in the last 3 or 4 years, as people realise these issues. And over the last 6 months, unfortunately, the issues around energy, the issues around raw materials, the accessibility, the cost, are all coming home to roost. And actually, we missed a huge opportunity I say particularly in the UK, where we had a real need. You know, we had an opportunity to springboard, and we're virtually thrown it away, frankly. And we are on the tipping point, so we've got a big job to do.
I think the other thing not to forget is that hydrogen still has to do a bit of pudding and proving in a way that electric vehicles haven't. So we mustn't forget that, you know, the buses that got deployed, they had reliability issues, the first generation. The stations which are being deployed for the passenger cars have reliability issues. So you can't point to a complete success story in the hydrogen space yet. I very much hope T stuff or Zebra programs and all of these things which are coming will do that. But we need to just be a little bit careful about kind of, well, you can see why a politician would favour a Tesla that they can drive versus a Mirai that they can't refuel, for example.
And I'd like to jump in here as well. I think it's worth acknowledging as well, battery electric passenger cars are good, you know, for the majority of people, for the majority of journeys. This is going back to that thing about averages again, right? So for the average user, for the average car journey, they use their vehicle twice a day, and they travel 7 miles on each journey. Battery electric is perfect for that. You know, that's your daily commute to and from work, dropping the kids to school, going to the shop once a week. That's a big advantage that battery has, and also the embedded network that's been discussed previously by earlier speakers. Big advantage for batteries. But as we start to roll out, as we start to get to that point where we want to reach 100% penetration of zero emission passenger vehicles, it's going to get tougher and tougher.
And that brings us to the end of this panel. So thank you. We have a round of applause for our panel.